right, today what we're going to do is we're going to do chapter 10, section 5. We're going to apply other angle relationships in circles. So if you take a look right away at the top, it says if a tangent and a chord intersect on a line in a circle, then the measure of each angle formed is half the measure of the arc formed. Well, what does that mean? Well, let's take a look and take apart that a little bit more. It says if a tangent line, this is the tangent line, and this is a chord, okay, they intersect on the circle, which is what they do, then the angle formed is half the measure of the arc. So in other words, if I take a look at angle 1 right here, all right, that is half of the measure of the arc. And if I take a look at the angle, it's A, B, and then it goes off this way. That would be half of arc AB. And you're going to notice that it's AB and not named with 3 letters, primarily because there aren't 3 letters, but then also it's a minor arc. If I take a look at the other angle, angle 2, which is right here, okay, I've got A, B, and then it comes off the other side, okay, and that is also 1/2, but it's going to be the measure of the arc ACB. The reason why it's named with 3 letters is because it's a major arc, and it goes from A, the start of the angle, and brings it all the way down to B. All right, let's take a look at this a little bit closer. If the measure of arc AV is 140, find the measure of angle 1. Now you can go, well, which way is AV? All right. If I looked at AV being this way, you're going to notice that it's more than 180 degrees, and that is not what this angle is. So they are looking at this arc right here, and you'll notice the measure of angle 1 is associated with that. So to find that, I'm going to go the measure of angle 1 equals, it's going to be the arc, and then it's going to be divided by 2. So the measure of angle 1 is 70 degrees. Again, the arc is always larger than the angle. So the arc always larger than the angle. So if you think of it that way, think of it's getting bigger and the arc's going to be larger, that'll be easier. All right, let's keep going. There are 3 ways that lines can intersect a circle. The first way we've looked at before. In fact, you'll notice it says review. If the point is on the circle and the 2 lines run like this, okay, this is called an inscribed arc or angle. With an inscribed angle, like we said before, the measure of angle 1 is half of the arc AB. Here's the arc AB, and that's the inscribed angle. Now that we've seen before and you have practiced, so that should not be hard at all, okay? Another one that we looked at that's a little bit review is if I have a circle and I have the center of the circle, this is called a central angle, okay? And if I do that, and this is, I'll call this A, B, C, and I'll call this 2, the measure of angle 2, and let's say that's 20 degrees, it equals 20. That also equals the measure of arc AC. So a central angle is the same as the arc measure. An inscribed angle you'll see is smaller, and that makes sense. The angle is going to be smaller than the arc. So there's some review based on what we've seen. Now let's keep going. You're going to notice that the intersection of the 2 lines are inside. You'll notice that's the inside of the circle. And so when I think of this as the average. It kind of helps you when you're trying to figure this out. So let's say I'm taking a look at angle 2, and you're going to notice that there's an arc here. That's angle 2. This is also angle 2, if you remember vertical angles. And so I have another arc here. Now notice that the intersection is not in the center of the circle. The angles are the same, but you'll notice that the arcs are not. And so to figure this out, what we're going to do, we're going to find the average. So I'm going to take the measure of angle 2 equals the measure of arc WZ plus the measure of the arc XY, and I'm going to divide it by 2. And that's how you would find out what angle 2 is. Again, what I'm going to do is I'm going to take the arc here, I'm going to take the arc here, I'm going to add them together, and I'm going to divide it by 2, and that's going to give me the measure of angle 2. Now, if I take a look at 3, okay, let's look at some of that information. So I have 3. This is also 3. They are the same because they're vertical angles. And if I take a look at the arc, I've got an arc here, and I've got an arc here. So to find that, what I'm going to do is I'm going to take the measure of arc, and I'm going to grab one of the arcs, which is YZ. I'm going to add the measure of arc, WX, and I'm going to divide it by 2. Again, if you think of it as like the average, the middle, it's inside, you're going to be better off. But notice that the intersection, it is not necessarily the middle of the circle. So just to let you be aware. And then finally, I've got the intersection of 2. Notice that the first one, it's on the circle. Notice that the second one is in the circle. And notice the next one, it's outside the circle. And so what we're going to do that is you're going to see 2 arcs are created. One of the arcs that's created is right here. It's inside the circle. You're going to notice it's smaller. And then there's the outside of the circle. Notice that it's larger. And so to do this, what we're going to do is we're going to take the measure of the larger arc. So the measure of arc EF, the larger one, I'm going to subtract the measure of the arc, the smaller one, CD, and I'm going to divide it by 2. So rather than adding them together, you're going to subtract them. But if you use that little tip that I used and said, well, this center is inside the circle, I'm going to find the average, it will help you out, okay? So when we are looking at the next problems, I'm going to call this one problem 1, this one problem 2, and this one problem 3. And when we go over the next couple of problems, we're going to use those different formulas. So we'll take a look. So let's take a look at this next example. It says, note that when 2 lines intersect outside the circle, it can look like this. So outside a circle, you're going to notice that I've got this intersection here, okay? And I'm going to call this A, I'm going to call this B, I'm going to call this C, and I'm going to call this D. The measure of angle, we'll call it 1, right in there. It's going to be the measure of arc CD minus the measure of arc AB, and I'm going to divide it by 2. If I go to the next one, I'm going to call this angle 2. I'm going to call this F, G, and E. Okay, I'm going to go and look at the arcs again. So I've got an arc here, and I have another arc here. So I'm going to go, the measure of angle 2 equals the measure of arc, EG, minus the measure of arc, FG, the larger minus the smaller, and I'm going to divide that by 2. Then finally, if I take a look at this next one, I'm going to call this angle 3. I'm going to call this HI. And I'm going to point out here J. That's going to help me with arcs. Okay, notice I got two arcs again. I got one here that's a little bit smaller, and I got one out here that's a little bit larger. So I'm going to come down in here and go, the measure of angle 3 is the measure of the larger arc, which is HJI, minus the measure of arc HI, and that's going to be over 2. So again, you take the larger arc, you subtract the smaller arc, and you divide it by 2. And notice that the intersection of each one of these, of the lines, is on the outside. It kind of depends on what those lines look like. All right, let's go down and let's solve some problems. So if I take a look at this first problem, think to yourself, where do those lines intersect? Okay, notice that they're intersecting inside the circle. And so if I go back to this slide, am I looking at 1, 2, or 3? I'm looking at 2 because the intersection is inside the circle. So essentially what I'm going to do is find the average. So I'm going to go back to my problem, and I'm finding the average. Okay. There are 2 different ways of doing this. Again, I'm looking at X. So if I'm looking at X, I am primarily looking at this arc and this arc, but I don't have those measures, but I can figure them out. And so this is how we're going to do that. I'm going to take 95 plus 154. So I'm going to add those 2 arcs together. And that gives me 249 degrees. So now what I'm going to do is I'm going to take 360 degrees and I'm going to subtract 249, and that's going to give me 111 degrees. So rather than adding these 2 up, I've already added them up. So the measure of angle X is 111, which is the sum of the 2 angles, divided by 2. So the measure of angle X is going to give me 55.5 degrees. All right, let's keep going and let's go to the second picture. You're going to notice on this picture, the intersection is right here, which it makes it outside the circle. So if I go back up here, which one has it outside the circle? Am I going to do 1? Am I going to do 2? Or am I going to do 3? I'm going to do 3, and when I do 3, I'm going to take the larger arc, I'm going to subtract the smaller arc, and I'm going to divide by 2. So let's go back to the problem. I'm going to take the larger arc, which is X. Again, this is 70, the angle that I'm trying to find. I'm going to take the larger arc, which is X. I'm going to subtract the smaller arc, which is 55, and I'm going to divide it by 2. Okay, so again, this is the angle measure. This is the larger arc. I'm going to subtract the smaller arc and divide it by 2. So now what I'm going to do on this is I'm going to use my algebra. I multiply both sides by 2 because 2 is in the denominator. So I have 140 equals X minus 55. I'm going to add 55 to both sides, and X gives me 195 degrees. All right, let's keep going. This is the next problem that we're going to do, okay? And I need to take a look at where it intersects. You're going to notice that this problem intersects on the outside. So let's go back and take a look. Am I doing 1, 2, or 3? I'm doing number 3 because, again, the intersection is outside the circle. So I'm going to come back down. Okay, the angle is X equals the larger arc, which is here. It's 192, minus the smaller arc. Again, that's inside the angle. That's 77. And I divide it by 2. So x equals 192 minus 77 is 115. Divide it by 2, and I end up with 57.5 degrees. Finally, let's take a look at the last one. Okay, I'm taking a look at the intersection. It's right here. Notice it's on the circle. So I'm going to go back up, take a look at my formulas. Okay, is it 1, 2, or 3? Again, 1 is on the circle, 2 is in the circle, 3 is outside the circle. This one is on the circle. And so that is going to be number 1. And all I do is take the angle. And again, the angle is smaller than the arc. So let's go back down. Okay, and this is x. But notice that 200's on the other side, like this is y. So there's 2 different ways of doing this. What I would do with this one is, rather than call this y, I would take 360 degrees and I'd subtract 200, and that gives me 160 degrees, which means this arc is 160 degrees. So the measure of angle x is going to be 160 degrees divided by 2, because remember, the angle is always smaller than the arc. So this ends up giving me 80 degrees. All right, so that's it for today. The main thing that you need to take a look at is, what type of angle am I dealing with? First of all, if it's a central angle, the angle is in the middle of the circle. I know that because it's going to have a point or dot in the middle, and the arc is going to be the same side as that angle. Then we dealt with the inscribed angle. That's where the point is on the circle. I'm going to take the arc, and the angle is going to be half of that. Then I've got the intersection is in the middle of the circle. So if you think middle, think average. I'm going to take the 2 arcs, I'm going to add them together, and I'm going to divide by 2. You just have to be careful which arcs you choose. And again, if I take a look at the arcs here, if I'm looking at the 2 here, this is the arc I'm going to work with, and this is the arc I'm going to work with. If I'm going to look at 3, which is here, this is the arc I'm going to work with, and that's the arc I'm going to work with. It's almost like a bow tie, if you think of it that way. Here are the 2 bow ties going that way, and with the green, this is the bow tie that goes this way. And it's the average. And then finally, the point is on the outside. And so when I do that, I'm going to take the larger arc, which is out here. I'm going to subtract the smaller arc, which is inside the angle. Both of them are inside. And then I'm going to divide them by 2. If you have any questions, make sure that you let me know.